I'm Kieran. This is Sebastian.
I'm not Kieran.
Yeah. Oh, so that's our first slide, isn't it? Who are these guys? We've been sitting here for most of the conference. You can go first.
Nobody told me that I have to tell something on stage. So, hi, Sebastian. Started to get involved in PHP in '98, and at some point in 2000, I came across testing, software, unit testing, software testing. All these strange ideas at the time at the university, and got really lucky that I had a professor that on the one hand knew that I existed, knew that I was involved with PHP and was interested in that, and he thought that I might be interested in unit testing, and he tried to inspire me to do something there and wanted to convert me to the dark side of Java because, as he put it, Java has JUnit, PHP doesn't have something like JUnit. So if you want to do unit testing, then you have to switch languages. And I may or may not have made the bet with him that that's not really true. And then a week later, I showed him the first prototype of what would later become the first version of PHP Unit, which has nothing to do with what PHP Unit is today. But still, it was a first step. And people often ask me why I did this, and it's not really the bet, but it's pain. I often think about, when I think about working on PHP Unit, as pain-driven development. I was feeling the pain of not having a tool that helps me make sure that my software works correctly. I mean, I wasn't doing anything world-changing, critical, whatever back then, but still, I was writing software. I wanted to make sure that it works the way that I had understood it should work, and there was nothing for that in the PHP world, which is not really true because there was something on SourceForge called PHP Unit, but it didn't work. And I tried to get in contact with the author, and he didn't respond. So at some point, I started to work on PHP Unit. And since I wanted to build a unit testing tool for PHP, I named it PHP Unit just because that name made sense. But I couldn't put it on SourceForge. I mean, you need to remember that was way back when. There was no GitHub. So you put your open source project on SourceForge. But the name PHP Unit was already taken. So what did I do? I just put it on cbs.php.net.
Does anyone remember CVS?
Without really talking about or thinking about what I did there. So that's how that happened. So who are you anyway?
Hello, I'm Kieran. We're a similar age, but none of my university professors gave me an interesting project to dedicate my life to. So I graduated in the late 90s and got a job in an advertising agency, making websites. And I didn't learn anything for about 5 years. We did lots of websites, but it was the same website every time. I learned a lot about life and dealing with people and nightclubs in London. But I didn't really pick up any computer science skills. And then I changed jobs. I went to work somewhere where they were doing this thing called test-driven development, using this thing called PHP Unit in about 2006. So basically, for the last 10 years, most days I've seen the phrase, by Sebastian Bergman, in my terminal. So I feel like we've known each other for that long.
And you may or may not believe me, but I had no really intentions, especially not evil intentions, by putting that into the code. Didn't really think about this at all. Yeah. Because the first version of PHP Unit was a line-by-line port of JUnit. And JUnit at the time just printed JUnit 3.8.1 or something by Erich Gamma and Kent Beck. And when I came to translating that line from Java to PHP, just put my name in.
But it's fun to make fun of you because of that. So yeah, I've been doing TDD for maybe just over 10 years. And about 4 years ago, I started using a couple of tools. One was BHAT. Well, I'm wearing my BHAT t-shirt today, which kind of exposed me to this BDD world, which is a sort of wider community across languages. And I also started using a tool called PHP Spec. And I talked about that yesterday. It's kind of boring. Which people see as like a rival of PHP Unit, maybe. And so a lot of the time, I took over the tool PHP Spec, and I'm lead maintainer now. And I have a lot of input into Bhat. I don't write much code, but I do talks and write extensions and kind of prod Everset to add features.
And it's one of the reasons why we're having this talk today, right?
Yeah,
because people think that we hate each other. So, I don't know, 3 years ago, I met Konstantin for the first time. And after his presentation, the two of us met and we talked, discussed about things, and people walked by and one guy stopped, looked at us, "You talk. You don't seem to hate each other." No?
Yeah. It's a very common question.
All these people on Twitter say, that tool is stupid and you should hate them and don't use that. And yeah, that's people on Twitter, that's not us. So
yeah. It's very common after a PHP Spec talk or PHP Spec training, people say, "Oh, so yeah, PHP Unit's shit. I'm glad I found PHP Spec." And I have to say, whoa, 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 calm down. I use PHP Unit nearly every project. It's just we use it for different things. And really, most people inside our community, we might sound very energetic on Twitter or on mailing lists, but most people, you end up finding you agree with them if you just talk. So that's kind of what we want to talk about today, isn't it? What we agree on.
yeah,
The aim of the talk was to sort of explain what tools are available inside PHP and how you choose your tools.
I'm pretty sure that at some point we will disagree, but
yeah, we might disagree on stage.
that's just to keep it interesting.
So we're not going to go through exhaustively every tool in PHP. That would take a long time. There's lots of testing frameworks, and something that's happened recently, maybe over the last 5 years, is that we've got more than one testing framework, and that is almost undoubtedly a good thing. So what we want to get from today is to sort of give you the tools internally to choose the tools that are going to work for you in your testing practice. It's not, this is the right way, it's here's how you make the decision. What kind of tools to use?
Yeah, basically, we want to enable you to make an informed decision of which tool to use, when, and how, and why.
So hopefully that's interesting.
Sounds good?
I can't remember what the next slide is. So Sebastian did this great talk. You've done it a few times. The 3 dimensions.
I've done that talk a few times over the last 2 years because at some point it occurred to me that well, let's roll back a bit. So a couple of years ago, like every month, there was at least one paper that came out, or a blog post, or an article, or a presentation where somebody said, "Look, this is my awesome way of categorizing the different kinds of tests," and I put them in the pyramid. And last time I counted, I had like 13, 14 different software testing pyramids. And of course, every time there are many different standards, or in this case, visualizations to do something. All of them are wrong. And of course, I know better. All of them are wrong. I have to have my own, and now we have n+1.
Yeah.
So
all of them are right for one person?
Yeah, sure.
Well, so depending on your context, you're going to find a way of testing that makes sense.
It's such a multifaceted area of software development that there is not really a right or wrong. It's just different ways of looking at the same thing. And some 2 years ago, it just clicked for me, and it made sense to think about this as a 3-dimensional category system that I apply to a test. So what is the goal of that test? What is my intent when I write this test? What do I want to achieve?
Maybe what problem are you trying to solve by writing a test?
Yeah.
Because often these things come from pain.
Yeah, pain-driven development. So there's a problem, there's pain, I want to make the pain go away. So why do we write a test? That's category number 1, or dimension 1. Second dimension is scope. How much of the software system do I want to involve in testing the thing, in solving the problem, in answering the question that got me started with this test? There are things that I can only test or verify or describe, depending on how you want to look at that, in a very large scope using a real HTTP client and a real HTTP browser and a server and whatever. But it's usually really good to do it in the smallest possible scope. So that's the second dimension.
Yeah.
And the third dimension is one that is most, well, subject to a matter of taste, I would say.
How do you write the test down in a way that you're going to be able to execute? Yep. And this is what leads you to choose a particular tool. You know, what way of writing a test makes the most sense for the goal I have and for the scope of the system I'm going to be testing?
How do I denote the test stimulus? How do I write down how I want to trigger some action in the system? Mm-hmm. And how do I want to write down that I get the expected result? Yeah.
So the form is the bit where you get to argue with other people about which tool is the best, right? First two are about best practice, and the form is, you know, this tool is the best one.
And as Kieran mentioned, over the course of the last 2 years, I've been giving a presentation called The 3 Dimensions of Testing a couple of times. And until yesterday or so, I thought that was really good, the 3 dimensions.
Now you have to pretend we had this discussion a long time ago.
Oh, we had this discussion a long time ago, like
Weeks
6
ago,
months ago,
when we finished
when
the
we proposed
slides.
the talk.
Yeah.
Not when we finished the slides.
So there's a fourth dimension. Does anyone know what the fourth dimension is? Time. Time is the fourth dimension. So my clicker stopped. Time is also very important. When do you write the test? Do you write it before you implement the system? Do you write it years later when someone else's crappy code gets handed to you? That is another huge consideration when you're choosing which tool is going to be correct or the most effective.
But there's also a second dimension to the fourth dimension.
Go on.
When do I run the test, or when do I perform the test?
How often?
Do I just do that in development, or is it useful for some tests to run them in production?
Or in staging, like the last talk.
On the stage?
Or in different levels of a pipeline.
Yep.
Okay.
Sounds good.
So we're going to talk about 4 broad categories of tests, and in each one we're going to look at these different dimensions and try and state some of what we think are the best practices. When we proposed this talk, we thought it would be great because we'll disagree with stuff and we can have a debate on the stage. And as we prepared, we realized we pretty much agree 100% on most things, so I might artificially start to argue on some of the points.
Boo.
Thanks. Thanks, guys. That's the supportive speaker community making the noise.
Yep.
So characterization tests, acceptance tests, integration tests, and unit tests. Before we start, who is doing some testing of any of these categories? Okay. And who tests things by putting it live and listening to whether the phone rings to tell you something bad happened?
If you have enough test units, you don't need unit tests.
I think that's a valid form of testing.
Your customers and users.
That's one of the most common forms of testing is, you know, we'll put it live and someone will complain if it's wrong. Some companies actually automate that.
That's the reason why some teams correlate data from their call center with their system metrics. So they see on a big screen on the wall, we made a deployment at 5 minutes past 10, whatever. And starting a minute afterwards, we have a huge spike in number of calls to the call center per minute, so something went wrong. So we roll back that release and figure out what went wrong.
Yeah. Okay, so let's start with... I clicked it twice now. I think you might have to control it. Characterization tests. Anyone writing characterization tests? You just don't know that you're doing it yet. Quizzes. So what's a characterization test? Well, we talk about the goal.
Yes, so what's the goal? The goal is not to make a statement about a part of the system or the system as a whole that what we currently have is correct. It's about capturing the current behavior.
Yeah. Why might we not want to write a specification?
it works like this right now. I don't know if the way that it works right now is correct or not. I don't care about that. But I'm about to make a change, maybe to some completely unrelated part of the system. But I want to make sure that this part of the system works exactly the same after I have made the change.
Yeah, and this form of testing is mostly valuable for systems where you don't know what it's supposed to do. The system where you got given it, some other developers worked on it before, it got handed off to you, you started calling it a legacy system as soon as you saw it, as soon as you looked at the code. The code doesn't really make any sense.
Yep.
But you want to capture what it's doing now so that an alarm will go off if that changes. And it might have changed because you've caused a bug, it might have changed just naturally, you won't know, you'll have to analyze. This keeps happening. So what scopes might you do this characterization testing at? You just want to be told if something breaks. The easiest level is the UI level. It's the easiest level to write tests because you don't have to care about the code. You can test from the outside. You can test across language platform.
Yep.
You can test across technologies. You pretend to be a browser if it's a web application. You do some HTTP, you run the JavaScript, you check everything still works. It's easiest to write.
It's the most expensive to maintain over time. It's the most resource intensive to run. It's the less precise type of test. When something goes wrong, you get the information, hey, something broke. That's valuable and useful information, but that information is not very precise because it just tells you, hey, something is broken, but I'm not going to show you where something is broken.
When you're talking to companies about their problematic test suites, it's very common to hear things like, we've got a Selenium thing that takes 5 hours to execute.
Only 5 hours?
Yeah.
My high score is 30 hours that I've seen.
And we've added a thing that runs the tests more than once and averages how many times they fail. Because if they pass 4 out of the 5 times, it probably works, right? And we're looking at getting a bigger machine to run it.
Yeah.
We're thinking about parallelizing it across a cloud infrastructure to run it in parallel. Yeah. And every time the front ender modifies the CSS, all the tests fail.
Yeah.
Because
work around the real problem by creating new problems thanks to parallelization instead of solving the real issue. But that's okay.
But sometimes that's what you have to do because you can't write any other kind of test. You need to, at the start of your introduction of tests, just say, I need to start to understand what's changing and when is it changing.
Yep.
Sometimes you can do characterization tests at the service level. So if this application you don't really understand has a nice decoupling between the UI and some kind of services, you can apply the same kind of practice at the service level. You look at what it does, and then you write a test that says it does that. Mm-hmm. And if it stops doing that, the test will fail. You don't have a lot of understanding of why it's doing that or what the requirement was. You're just mirroring, here's what the code does, I write a test that does that. Mm-hmm. And you have similar pains when the logic changes. Okay. When do you write characterization tests? Pretty much by definition, it's afterwards. You're looking at something that exists and you're saying, it does that. You see that it does that, and you write a test that says it does that.
Yep.
So it's not going to do any of this integration into your workflow. It doesn't really matter when afterwards you write them. It's not kind of built into your agile process to write characterization tests. It's something you're doing to comprehend this ball of mess you've been given. Is anyone in that situation? Yeah, it's fun. If you choose to think it's fun, your job gets better. See it as a challenge. Okay, so we'll look at some examples of ways you can do this and tools you can use. The best practices, we think, when you're writing characterization tests, is to realize it's going to be painful, they're going to be really annoying to maintain, and probably you'll want to phase them out eventually. So a very good strategy for a legacy site is to add a lot of characterization tests so that when you make changes, when you start refactoring, you get told what's broken. But then to do that refactoring, and when you've written, proper tests later, you can take out these end-to-end things. When you're choosing which tool to use, it's all about ease of use. Characterization tests are something you want to generate rapidly. You want to be able to cover as broadly as possible an application. So something that's easy to use makes sense. And probably something I've noticed with characterization tests is when they fail, people don't really fix them, they just delete them. Because often they're too painful to fix. You just delete the old test, and then you look at what the system does now, and you write a test that captures that, as long as it does something sensible. And yeah, it's going to be painful, so try and limit the time frame.
It's not fun.
So a tool you can use is called Bhat, which is a Cucumber tool for PHP. And this is not how we, the core Bhat team, want you to use Bhat at all. It's possibly what about 80% of teams are doing. But there's this extension, Mink extension, that adds lots of built-in steps for Bhat. So you can write this into a file, execute it, add a config file that tells it how to connect to a browser. And this will get executed against your real application. So here it'll go to a URL, fill in a particular field, hit go, and check that we found 100 items. So who's that good for? It's not in PHP. So that's good for some people. Some organizations have a person called a tester, and the development team think the tester's job is to write the tests, not the development team. So that poor guy stuck on his own, having to knock out characterization tests, can use this kind of DSL to write them quickly, just by adding stuff to a text file, typing this into an IDE. Maybe a product owner could write it if they had a bit of spare time. Maybe someone non-technical. I think that's the niche this is in. Because it's not really related to the core use case of Bhat, the next version of Mink extension will take this functionality out, but it'll pop up somewhere else in another extension with documentation that says, don't use this. But it'll still be there. So I have seen teams use this effectively to quickly generate, one person just sits there writing this kind of thing, quickly generate broad coverage of an application. But, only if you don't know PHP. Only do this if you don't know PHP.
If you do know PHP, you might want to use something like this.
Yeah.
So this is a characterization test in the end-to-end scope implemented using PHP Unit, and a very tiny plugin for PHP Unit that connects Mink with PHP Unit so that you can do browser-based testing. And then you can do things like visit this URL, and it gives you a page object. And you can tell the page, for instance, to fill out a field like search with blue jeans and press the button. And then it does some things, submits the form, waits for the response, and abstracts all of that implementation detail of HTTP and the web away from you. And then you can just use regular PHP Unit assertions on the HTML response that comes back, for instance, and say, this test should be considered successful, and only then successful when the HTML text, the text without the HTML tags contains 100 results found as a string.
It's configurable through Mink.
It's configurable.
So Mink's an abstraction layer across Selenium and other drivers. So it's got a subset of the functionality.
So it has, for instance, something called, what's it pronounced again?
Gut.
Gut? Gout? Gute? Whatever.
Or you can hook it into Guzzle, you can hook it into Phantom.js, things like that.
Fake browsers, some real browsers.
Mink was actually written for Bhat, but it's a standalone project and you can integrate it into PHP Unit. So if you're writing this test afterwards, if you imagine what someone writing this test is doing, they're opening the page in a browser, they're figuring out the URL, they're then inspecting what the search box is, hard-coding that, they're figuring out what the button is, hard-coding that, they're looking to see what the result is, they're hard-coding that. This is definitely, they're capturing the existing behavior. They're not designing it. They're just adding this afterwards so some kind of continuous integration server can say, you've broken stuff, go and look at what's changed. So this is a better option if you know PHP. If you're a PHP developer and it's going to be quicker for you to type this in with your IDE that does autocomplete and is going to create the class for you, rather than having to type in text like bhat.
Yep.
Plus Mink extension. But in both cases, someone has to sit there and write the thing, which may even still be too much overhead.
And if you don't want to type?
If you don't want to type, there are other options. One, quite old one now, Selenium IDE, lets you record a bunch of clicks through a website and then save that as a script. You can even save it as PHP unit.
You can save it in lots of different formats. I would recommend to not use Selenium or any type of Selenium with PHP unit, because PHP unit cannot run tests in parallel, and these tests can tend to get slow. So you want to have parallel execution. There are far better Selenium clients for Selenium RC, which is Selenium Remote Control, than PHP and PHP unit.
And actually, we didn't say, for this kind of test, you can also use tools from other languages.
Exactly.
Because it's just capturing end-to-end.
This is end-to-end, this is black box. The testing tool does not necessarily have to be written in the same language as the application that you're testing.
And we've been talking about this for a long time. Don't get the idea this is a good idea. We're just covering this so we can get to the good stuff in a minute. We're trying to make it clear that this is the painful side of testing.
So the default format of Selenium IDE when you save a test is HTML. So you get an HTML table. Every action, everything that can be recorded, what a real user can do with a mouse and a keyboard in a real browser, is written as one row in a table, and the table has 3 columns. First column is the action, and column number 2 and column number 3 are the arguments for that action. And the reason why that's a table is you can open that table in the browser and then hit the print button.
Nice.
And it also works the other way around. If you don't want to use the Selenium IDE and still want to type it by hand, you just use Excel and do a spreadsheet and write a table and save that as HTML. I'm just giving you anecdotes. That's what somebody told me like 10 years ago what the idea was.
Yeah.
I didn't believe him back then, and today I hope that nobody does that.
So the point is to pick one of these that's easiest.
Yeah.
If typing sentences into that gherkin format from the bhat example is easiest, do that. You want to do something lightweight, quick. It's not going to be there long term. If typing PHP into PHP unit test case is quickest for you, do that. If using a tool like this for whoever's in the company's tasked with generating these things, use the tool.
You need to find what works best for the person who writes this. There are plugins, for instance, for issue trackers, like Jira and others that support you in writing this, and then that somehow turns it into something that is executed by Jenkins via Selenium or something.
And if you have someone in your team who is tasked with covering a legacy website with this kind of thing, be nice to them. Buy them some donuts or coffee or a beer regularly, and tell them how much you appreciate the work they're doing, because they're not having a good time. A tool that's a bit like this that I've been using, they don't pay me, is Ghost Inspector. It's a kind of crappy tests as a service platform. So you record a route through a website, it saves off into their cloud thing, it can run against your platform in continuous integration. It's got a nice, cool interface so you can show it to business people. They take a video of the failed cases and take screen grabs and stuff. So you have to pay for it, but we've found it pretty effective on some of our sites, especially where we have this challenge of, someone in the testing team is going to have to cover all the main business paths because we're going to start breaking stuff soon as we re-platform. That's pretty much it for characterization tests. Anything to add?
That's about characterization tests at the UI level, right?
So only do them if you can't do all the stuff we're about to talk about for the rest of the talk.
Yes.
It's for legacy sites, it's for getting some kind of safety, confidence, that kind of thing. Cool. No, we didn't talk about this thing.
Yes.
So you can do characterization tests not at the UI layer. And I recently found out Sebastian has this crazy tool he wrote that he's now going to tell us about.
Yeah. So don't get fooled by the name just because it's called de-legacyfy. It doesn't turn your legacy code base into something clean, but it helps you with the process. So there are a couple of best practices and patterns that I learned over the years that work well when modernizing a legacy code base. And when I can codify and put some of those practices into a tool, then I do that and I put it in there. And the first thing that I put in there has to do with characterization tests. A couple of years ago, I was working on site with a team and they had a legacy code base. They wanted to get started with testing. And they didn't want to do all of their characterization tests on the UI level for the obvious reasons. But they also didn't want to manually write all the characterization tests for things, for the couple of classes that they had that could be instantiated in isolation from the rest of the application. It had methods that you just could call and get a result back and verify that through a test. So the idea that we had was, wouldn't it be nice if we could send real requests to the application and capture a trace of all the function and method calls that go on in the request, and then tell a tool, hey, I'm interested in this method of that class, and then filter out all the calls to that method, store the arguments that are passed into that method, all the data that goes into that method, and capture the return value for that. And then automatically generate test code that can be run using PHP unit. And that gives you, within a couple of minutes, in our case, where we worked, a couple of 100 characterization tests for some of the core business logic, which was really nice. Just needed to bribe Derek to expand Xdebug. But it worked. You just need to know how to bribe someone.
So it sounds like a crazy idea. You in production look at every input and output to a particular method, and then you generate tests that say this input will produce this output.
Yes.
Cool.
Of course, it doesn't capture side effects.
Yeah, so it depends on state.
Yeah.
But it sounds interesting, right?
But there's someone that's interested in maybe doing a thesis on doing some more analysis of that trace information and automatically generate code that creates test doubles, for instance, or captures what's going on with the database and stuff.
Cool.
So maybe that comes up at some point in the future.
Yeah.
Would be nice.
So let's get to the good stuff, acceptance tests. So why do you write acceptance tests? Acceptance tests are something you write when you care that the system matches some kind of requirements. So characterization tests, you don't know what the requirements are, you've just got this code. Mm-hmm. Acceptance tests, you know what the requirements are, and you want to write tests that validate the real system against those business requirements. So those requirements probably came from a human, probably someone asked you to add a feature. They're also a good way to get feedback on proposed implementations. So if Sebastian's the business person and says we need this new feature, I can generate some acceptance tests and say, is this what you meant? If he can read what I'm writing, I can show him the tests and say, is this what you wanted me to build? So it creates a feedback loop between us. Having conversations on this kind of level, requirement conversations, really helps you understand the business. And a lot of this is what BDD is about. It's about understanding requirements is probably the hardest thing we have to do in any of our workflows. You have to understand what's in the head of this crazy customer who's telling you to do stuff and deliberately feeding you requirements that break your existing model.
It's about communication.
Yeah, so if you can have a good conversation with somebody about what the system's supposed to do, and record the output of that conversation, and then automate your test based on that recording of the output that they've had a look at and validated. End to end, you have a lot less misunderstanding, better feedback, etc. Also, it documents the behavior of the system for the future. So the next guy who then, the person after you who thinks your code is a legacy application, at least they'll have a test suite that explains this is why we built this feature. So maybe having it in a readable way is going to achieve all of these goals. So yeah. Next slide.
So where can you apply, in which scope can you apply these type of acceptance testing? Like we said earlier, you can basically do everything at the UI level, but you don't want to. But it's the easiest for most people to do it at. You can do it on the API layer, on the service layer.
Some kind of REST interface, maybe.
Yeah.
You can apply acceptance tests directly to services inside your application. And as you go down this list, it's getting more and more efficient. It's getting easier to maintain. UI tests are hard to maintain, and there's actually more stuff involved in the test. You have to set things up, start a web server, something times out and the test randomly fails. If you're testing directly at a service layer, so you're applying acceptance tests to your objects, there's not a lot that can go wrong. You're in a process inside PHP. There's not too much that can go badly wrong. Lower than the sort of service level of tests, the code's probably too disconnected from the real requirements. If you're looking at a method on a class, it's hard to draw a direct line between that and something the customer wanted. So you can't really do acceptance testing on very small objects. Maybe if you've got a feature that only one object implements, right?
Yeah, or if you have an object that implements a core concept from the domain. Like, I don't know, you have an object called a contract, and there are a couple of things that you can do, you should be able to do with a contract.
Yeah.
And that is something that is very low level. It's implemented in the smallest scope possible, but it's still something that a non-developer cares about and can read the output of the test tool or read the test itself.
Yeah.
And it makes sense to them.
So a lot of people think acceptance testing means acting at the UI layer. There's this feeling that because the user uses a web browser, it'll be best if we pretend to be a web browser, and that's how we write our acceptance tests. The other side of that is there's a huge cost to maintaining this stuff, and there's a huge disconnect.
Yeah. I've worked with a couple of teams that told me, well, because it's so easy to use the real browser and do everything end-to-end with a tool such as Behat, we thought that this is the way that we should use the tool.
Yeah, I spoke to
It's common misunderstandings, common misconceptions.
I spoke to a customer who said it would be easier to do this at the PHP level, but you're supposed to use a browser.
Yeah.
Which is wrong. Also, if you only test through the UI, you don't apply any pressure on yourself to have good services inside your application. If you're only testing through the UI, you can stick all of the logic in the controller, and those acceptance tests will still pass. So adding tests at a service level will give you a bit of pressure to say maybe the different parts of my application, the different use cases, the different services should all be represented by separate objects inside the system. And driving from acceptance tests will mean that the API of your services corresponds very directly to the kind of actions users take. So you end up with a service that has an API that's very similar to the language that the business uses, and similar to the use cases the business uses.
Yeah, and if you only do acceptance testing on the UI level, then you only take care of building the right product or building the right software, which is a good first step, but it doesn't force you to care about the internal quality of the software. It doesn't care about, you don't care about then that the code is actually well-crafted, clean code, and testable.
Yeah.
That's what you drive with other kinds of tests.
Okay.
Cool.
When do you write acceptance tests? Ideally, before implementation. It's because writing an acceptance test, or at least the outline of an acceptance test, is part of understanding the requirements. So to be able to start working on a feature, you have to kind of understand what you're going to build. It's good to have a conversation with a person about what should it do. And you take that opportunity to write the outline of your test. This is something we maybe disagree with. I think if you use a tool like Behat or Cucumber, you can write a lot of the acceptance test before you even commit to doing the work. So in a team that's doing Scrum, I would have the outline of the acceptance test before sprint planning. It's something you can do as part of your reviewing of stories. When you're talking about acceptance criteria on stories, you're talking about what acceptance tests we'll be writing. As long as it doesn't take a long time to write them, right?
Yeah.
It depends on the tool.
So by the time you commit to do something in the sprint, you should have the acceptance criteria written down in a way that everybody understands and can actually commit to.
It's okay to have some of the acceptance criteria in a couple of question marks.
Yeah.
As long as you've, as a team, agreed, we'll go into it knowing that there's this area that's...
Sure, but the criteria have to be somewhere, and I don't really care if that's in a Jira ticket or in a sticky on the wall or in a PHP unit test that uses test docs notation or if it's in a BHAT specification or whatever works for you, as long as it's written down somewhere in a way that all stakeholders can understand.
Yeah. And it's really hard to write acceptance tests afterwards. It's hard to go back in time and say, why did we build this?
Yeah, if you write it afterwards, it's a characterization test.
Yeah. If you write it afterwards, you'll naturally just look at what the system does and say, yes, that's what it was supposed to do. And you may maybe capture too much, capture it in a too brittle a way. So best practices are, write your acceptance tests in a way that it's easy to get feedback from the business. Is this the right thing? It might be after you've implemented it, you show some output, reflect back to the business and say, is this what you wanted? It might be you can write the outline of the test, show it to the business before you commit too much time into implementation. They have to be readable by the people who need to read them. So if it's only PHP people need to read these things, or people who can squint a bit and understand what PHP is kind of doing, you can express them in a PHP manner, and that will be more efficient. If you're going to have to show them to business analysts and stakeholders, writing them in a way that's almost like English, or whatever language you work in, is going to be much more effective. And it's probably a good idea to start at the bottom. So your first aim should be, can I acceptance test this as a service? Can I test just part of the system using an acceptance test? For a new system, a greenfield project, that's always possible. For a legacy system, can I isolate part of the system and express the change I want to make?
Really try to avoid end-to-end.
Yeah, end-to-end tests are always painful, but you need some of them to know the system works.
And there are multiple dimensions of pain when it comes to end-to-end tests. So don't go there.
A healthy thing to have is, if you've got a core domain model that works, and you've actually tested all the business cases against the core domain model, you know it behaves correctly, then you can start to think of your UI layer as like a controller, not an MVC controller, a remote control for the domain model. So you're just testing, is my UI plugged into the domain model that I know works? When I get a new keyboard, and I plug it into my computer, I know they've tested the keyboard. So I just hit like 2 buttons, check something happens, check it's plugged in. I'm not going to check every key sequentially to check they all work, end to end. So some examples. We're going a lot slower than I thought. This is a BHAT the way we want it to be used more. So we write the scenario based on a conversation we have with a stakeholder. If you've not used BHAT, it's a cousin of a tool called Cucumber. So I was talking to the stakeholder. They said we need to apply sales tax correctly. And I wasn't sure that I completely understood how sales tax works, so I gave this example. So if I buy something that costs 100 euros, when it goes in the basket total is 120 because it adds the tax, and the stakeholder says yes. So using this style, you can have this kind of test outline and use it as a validation step. And that's actually valuable even if you don't automate this. It makes it clear, removes some ambiguity. Maybe not in this case, but when you have more complicated rules, it's good to give an example and say, so in this case, this is what should happen. And the business can say, yep, that's correct. So at the service level in BHAT, we then, at the same time we're implementing the code, we have to tell Behat, how do you exercise this test in PHP? So I have to create a basket. This is the object, this is the service I'm testing. And it has a dependency. It depends on a catalog. So I'm going to make a kind of fake catalog. This can be a very simple thing that keeps the data in an array. And for each step in the English language scenario, we have a pattern that matches a PHP method. So the product, blue jeans are priced at 100 euros. If a product is priced at cost in the catalog, we get a couple of value objects, and we call the price method on the catalog. And if this is a new project, I'm trying to align this method with the wording that we used when we were talking to the business, because that's always a good thing to do. When I add a product name to my shopping basket, so on the basket object, I'm going to call the add method with that product name. Then the total should be this. I check that the total is what was expected. So it's quite a simple test. It's all in PHP. But it's going to test that the basket object behaves correctly, without any external dependencies. You can do the same in PHP unit. Do you want to talk about this one?
Yes, you can do the same with PHP unit. So basically, you have the same PHP code inside the PHP unit test method. You create your in-memory catalog. You create the basket object that you want to test. You add the item into the basket. And then calculate the total and assert that that is the expected total. And whereas with Behat, your test looks, or your test is readable by a non-developer, you can get PHP unit to produce output that is readable by a non-developer using a feature called test docs.
It's beautiful.
That's what the HTML output of test docs looks like. A couple of conventions come into play, and you have to help PHP unit a bit by coming up with meaningful test names. Please don't use test 1, test 2, test 3, test, and so on. Also not test and then the name of the method that you're testing. That's not how your test should be named. But come up with concise, descriptive, meaningful sentences that capture what the test is about.
Yeah.
Basically the same that you do with Behat, you just write it down in a different way.
Yep. So,
And then PHP unit looks at this test case class, which is named basket test. It gets rid of the test suffix, because by convention we're testing something called basket. And then it transforms a test method name, test sales tax is applied, into sales tax is applied, and adds a check mark when it's working. And that's it.
So how do you choose between the two approaches? How do you choose between the two approaches? With the Behat example, you can show that English version first, and get feedback. Is this correct?
Yep.
If you don't have that opportunity, it's probably a waste of time.
Mm-hmm.
I've met some teams who think Behat's the cool tool to use, and they never get to speak to their customers, but they sit there writing English language Behat things and then automating it immediately afterwards.
Yeah. The fundamental issue there is that software development is more about human-human interaction than it is about human-machine interaction. It's really, really easy to write code that the computer can execute. It's hard to write code that is readable. It's at least as hard to write down how the code should, or what the application should do, how the code should behave.
Yeah.
And none of these approaches are useful to their fullest potential if it's only the developers that look at this and discuss this and work with it. It requires buy-in from the other stakeholders, from the QA people, from the business analysts, and so on.
So I think this approach makes sense either if you have all the stakeholders somewhat technical and can read it, or if you're iterating quickly enough and have enough contact that you can go off, write the code, and then show the test docs output almost immediately.
Yeah, I can you go back to the PHP unit? Mm-hmm. I can just write an empty test method and run that and get the output and show that. That's about the same effort, I would say, than writing the Behat spec without the context that puts it into action.
Yeah. Whereas for me, because a lot of the practice we have in our company is about having lots of scrappy conversations with post-it notes and writing this stuff down, it translates naturally into this for me. So we agree to disagree.
Yeah. We don't really disagree. It comes down to what works for your team, for your project, and what works in your process and how you want to structure your process.
So we'll go a bit quickly through this next bit, but because of time.
Doctor Who will help us with the time.
Yeah. Once you've comprehensively run these acceptance tests across your service layer, you then probably should check that the website works. Probably. You do want the UI to work. But you don't need to rerun all of these things at the UI layer. You can just run a subset. Enough to give you confidence that your UI is plugged into your service layer. If you have 50 different basket pricing scenarios that all work with the basket object, you just want to check that
one of them works.
The output of the basket object is put in a div, and so you only need to run one of them through the UI. So with Bhat, you can take the exact same Gherkin scenario and just automate it differently. And we normally use tagging of some sort to rerun a subset using a different set of implementations. So it's kind of the same thing, but this time instead of the setup's the same, but this is probably going to be doing an insert into a real database because it's a real catalog with some complex database connection type thing. All that pain of setting up end-to-end tests. And then when I add the product to the basket, it's going to visit a particular path and press a button. So instead of a method call, adding to a basket now means a UI interaction. And when I'm checking, instead of checking the result of a method call, I'm checking that an element's on the page. But the outline, the skeleton of that test is the same. And that's quite powerful to me. Do the same in PHP unit. Give it the same title. Right, make a real catalog. Do that UI testing stuff. You have to remember to start the web server or have a vagrant box or something, or I guess containers are trendy now. So you'd have some Docker compose that makes all your containers. It's harder to run on an aeroplane, that kind of thing, when you're not connected to the Docker repository.
Whatever.
So the point here is acceptance tests can be at these different levels, but doing them at the service level is probably easier. And it probably helps you drive the design of your services better. It probably will encourage you to have a nice detached service layer. This clicker works about 20% of the time, so. Brings us on to integration tests.
Yes, integration tests. So we talked about slightly larger tests like end-to-end and acceptance tests and so on. We mentioned that there's something really, really small called unit tests that we haven't gotten to yet, but there's also something in between, and there is, I think, no word, no term in the testing world that is more overloaded and more ambiguous than integration test. On the one hand, because everything that is not a unit test and not an acceptance test somehow falls into this magic catch-all category of integration tests. But also because there are many different types of things that you can test in integration. So for instance, you have two components, and just because you verify that both components work correctly when they are isolated from each other does not necessarily mean that they work correctly when they're used together. NASA can tell you really interesting stories where they forgot integration tests and ended up doing disintegration testing because they split the development of a navigation component for a probe that they sent to Mars between a team at NASA and a team at the European Space Agency. Both teams tested their stuff rigorously, isolated from each other. Due to lack of communication, none of the teams asked at any point in time the other team, which unit of measurement are you using? And you can guess what happens. The poor probe arrived at Mars and crashed. And all because the one team was using imperial units and the other one was using metric units, and they never ever talked about this. There was no integration testing, so you don't want that. So what can you do with an integration test? You can test two components integrated with each other. You can test one component of your software, does it integrate correctly with a third-party component? Does it integrate correctly with infrastructure services like a persistence backend, database,
File system, web service.
NoSQL file system, whatever? Does it correctly talk to a service over the network? Whatever.
Because most of your other tests, you don't want to get involved in that messy detail. We've talked about limiting end-to-end testing already. It's good if most of your tests aren't really involved in the infrastructure, in the I/O that's going to be happening. So testing integration with concrete infrastructure, testing that when you plug in a real database or you plug in Mongo, which is a real database, I guess, stuff does work effectively.
Yeah.
Also testing communication across boundaries inside your application. So Marco talked a bit about this in his talk. You might have completely isolated areas inside your application where you're just exchanging values, or you're exchanging, you're not crossing entities. You might have separate bounded contexts. So testing them individually and then testing them together is probably a good idea. So generally, it's a large-ish part of the system. The kind of acceptance tests for services we talked about are integration tests, but they're integration tests with a purpose because they're being driven by requirements.
It's just a different way of looking at the same thing, different goal.
You should focus these integration tests not on your core domain. So you should know that the core of your object domain works, and then you can test that it talks effectively to infrastructure from its edge. Maybe there's an interface that defines how it talks to some other system. You just test that the adapter for that interface and the real system work end-to-end in that part of the system. And anywhere where your system interacts with third-party code. We might talk a bit more about this in a minute, but we both try and not really interact with third-party code at all inside our core domains and isolate it out to the edges. So then you need to check that your lovely abstractions do work with the real infrastructure. You may need to push the button. So you tend to write integration tests after you've implemented the feature in your core object model. You tend to do it at the point you're starting to work out how you're going to interact with the real infrastructure. You've just installed that weird new database and you're trying to figure out the API. That's when you're writing the integration test, right? Maybe you've got some existing integration that you don't feel is adequately covered by your end-to-end acceptance tests. You want to add an extra suite of stuff to give you some confidence that it works the way you think it works.
Maybe you need to integrate with a really weird web service, and you want to make sure that when something in the other tests for the system breaks, that it's not related to your stuff, but it's because the web service is flaky again.
Yeah, I mean, a recent integration test suite I wrote was because a web service kept breaking stuff. Every time they deployed, something would break, so we needed to write a comprehensive integration test.
Quite common.
And you write these when you don't have an end-to-end acceptance test that covers it. You don't want to duplicate at the two levels. If you have an end-to-end acceptance test covering a particular part of infrastructure, you probably don't need to write extra integration tests. But maybe if you've got loads of end-to-end acceptance tests running against a particular database, you might want to remove them or minimize them and write integration tests instead. I've been talking too much, Sebastian. Why don't you talk? I've been talking too much.
Yeah. So best practice, use a tool that works for you. Use a tool that has convenient integration or convenient support that makes it easy to write and run tests that integrate with a particular type of infrastructure, for instance. For instance, if you have a piece of your application that needs to talk to the database or some other sort of persistent storage, then you're doing basically database interaction testing, which is a subset of integration testing. And if you're using a relational database, there's a really good extension for PHP unit called DB unit that really makes that as painless as possible. It doesn't make it magically quick, but it makes most of the pain go away.
Yeah. So when you're integrating with some third-party infrastructure or third-party library, look and see what tools they've provided you to help you test. Some frameworks ship with a test harness. ORMs sometimes have some help for testing, that kind of thing. And make sure that these things are isolated from your core domain. So architecturally, you want to have this nice, pure core domain that has some concept of how it interacts with the infrastructure, and then some messy stuff in a separate namespace, maybe a separate code base.
Put the messy stuff in quarantine so you can test your precious business logic, domain logic in isolation from all the mess. So,
yes, so BHAT is just for acceptance testing, really. So you can't use BHAT. It's too big for PHP spec.
Probably PHP unit.
I would always use PHP unit for this, unless there's something really specific for the tool I'm integrating with.
So this is what a typical database test case looks like, or database interaction test looks like with PHP unit. You extend database test case. You need to implement two methods, get connection, which creates an object that wraps around the PDO connection, and you implement get dataset, which describes the state of the database that you want to have before each test. So it takes care of cleaning the database and giving you a well-defined state when your test starts. So one test breaking and leaving the database in an invalid state should not have an adverse effect on all the tests that come afterwards, and DB unit takes care of that.
It's very convenient.
That's very convenient.
And then the actual test, I try not to really have any evidence of the infrastructure I'm talking to in the test. So here I'm instantiating a catalog that talks to a real database, but then I'm testing it by calling its method. So I'm testing it by calling price, which is going to insert some kind of price record. It's going to persist it somewhere. And I check that when I look up a price, the right value comes back. An advantage of doing it this way is that when I switch infrastructure and start using some other way of persisting the data, the tests are still pretty much valid. I'm just going to have to implement against some other persistence layer. And actually, I know some of the guys at Cucumber are testing multiple different persistence mechanisms by having this stuff in an abstract class and then extending it for the different platforms and doing the fixture stuff differently for the different platforms. Cool. So don't do too many integration tests.
No.
Favor acceptance tests where you can talk to the customer, but they're a handy mechanism for the stuff that the acceptance tests miss.
So with 8 minutes left, we finally get to what the two of us care about the most, probably.
Yeah, let's fight.
Final unit tests.
I'm standing this far away, so it's more dramatic when I run at you.
Now you scared me.
It's going to be like Mortal Kombat. So why do we write unit tests? That's a good question. Acceptance tests are going to tell us that it fits the requirements.
Yes, they tell us that we built the right product.
Why do you need anything more than that?
Because they don't tell us that we're building the product right.
Ah, that's nice.
They don't force us to write clean code that is actually testable and maintainable over time, and all these other nice things about code that Raphael talked about yesterday a bit. And
So from a testing point of view, there's an optimization thing that if you test all of the components individually and you check they're right, it's more likely when you put it together, it's all going to work. If you imagine a factory that's making a printer, if they didn't measure any of the components at any stage and they just put it together as a printer, it probably wouldn't work.
Well, with some companies that build printers, I'm not sure that they do that.
So it catches errors earlier. Unit tests are normally quicker. So if there's a test that's caused by a bug in a particular class, rather than some big coordination error, that unit test will fail and it's easier for you to debug, find that error.
And where the acceptance tests serve as documentation and specification for non-developers, the unit tests serve as documentation and specification for the developers.
Yeah, to help you grow the system over time. And acceptance tests force external quality. It has to do what the customer wants. The unit tests are going to drive internal quality. So unit test something, you have to be able to instantiate it without stuff happening. It has to be able to do its work without being massively coupled to any other objects. For you to stay sane, it probably has to not talk to too many other objects, because you'd have to instantiate all of those for the test. So it drives you towards thinking about objects externally first and keeping them nice and clean. So your unit test, it used to be like small parts of the system. Most of the time now people will say you should probably test classes individually rather than little networks of 3 or 4 classes. I generally don't bother isolating from value objects.
I don't isolate from an int or a string, so why would I isolate from a money or an email or whatever I use as a value object? Doesn't make sense.
So I often see people trying to make doubles of value objects, and there's 50 lines of code explaining how the value object should work. You could just use the value object.
I really hope that developers that use programming languages that have where everything is an object don't double their int object or their string object or whatever.
One day we might see that in PHP. No. And extremely small units of code. A lot of the, let's not go into different styles, but there's a style of unit testing where you don't mind too much if you've got something that starts as one object and you split it into smaller objects later, you can still keep one test for that bunch of stuff. But just keep it as small as is reasonable for your application. And you write it just before you implement the code. Okay?
That's good.
Is that it?
Nobody disagrees. Go on.
Okay, I have a slide with maybe.
Maybe. Okay.
The best way to write unit tests is to do test-driven development. Write the test first. It will change the way you program. It will change the quality of your output. It will change your workflow to a much more calm, iterative workflow. But maybe you've been told you have to write tests with every commit. Just try and do it soon after you write the code while it's fresh in your head.
Doing test-driven development is not something that you can do immediately when you start testing. You need to master the tool first. You need to get an understanding for what can you test, how can you test it, and so on. And then at some point, you want to write the test first, and then it works.
So maybe you write the code and commit it, and then you realize you forgot to write the tests, and then write the test and commit them.
And then rewrite the Git history? No.
And then squash it, so it looks like the test came first, reorder it, rebase it, and then push it.
Yes.
That's what I do on my open source projects.
Okay.
Just pretend there were no mistakes, everything happened in the right order.
Just don't share code with the rest of the team. Don't push stuff when the tests aren't there yet.
Yeah,
that's a good first start.
If you all pretend you're doing TDD, everyone else on your team will think they're the only one who's not doing it, so eventually everyone will be doing TDD.
Peer pressure.
Okay. Oh, 2 minutes. So, writing a descriptive style, your colleagues are going to have to read it. It should be something that describes, like you're telling a story, what this object does. If you're going to interact with other parts of the system, double them. So make a fake thing that you talk to instead. But don't get too hung up on that. Be pragmatic. Don't start doubling value objects. Maybe some very trivial classes. If it makes the test more descriptive, it's okay to use them. If it's not going to be too much trouble when they break.
Mm-hmm. Don't test other people's code.
Yeah, don't test other people's code. So if you extend someone else's object, I mean, maybe address that first. Maybe don't do that. But if you extend someone else's object, don't get too worried about testing the stuff you're inheriting.
It's their job to test their stuff. And if they don't test their stuff, then why the hell are you using it?
Yeah. Don't double other people's code. Don't talk to anyone else's code inside your core. So instead of me talking to Doctrine, for instance, just to pick on Marco, if my code talks to Doctrine, I have to double Doctrine and have to write a unit test that's got a little example of a conversation between me and a Doctrine thing. And if I forget to call flush, the unit test doesn't know that.
Yeah.
It'll pass, and then in production it'll fail. So maybe I make an interface that describes, I want my catalog. Here's the interface for catalog. It has a save method. Mm-hmm. price method. Nice domain-centric method. There's an interface. And I double that interface in my core tests. And I've got a nice happy core. And later I have to write a test that checks that implementation actually saves stuff to a real database using an integration test.
Makes sense?
I feel like I'm talking too much. Oh well. And that's it, really. Apart from that, the tool you use to write your unit tests is 100% a matter of preference.
Yeah.
So the only concern is this descriptive style, and your colleagues are going to have to read it and understand what it does. So if you write it using PHP Unit, 99% of developers will have used that, I would say, at some point in their career.
That's very optimistic. But
All right, 95% of developers will have used PHP Unit. Probably most projects that write unit tests.
yes,
You're definitely winning.
definitely that.
So if it's going to be read by a general audience, PHP Unit's an amazing choice. If you look at it in PHP Spec, it looks pretty similar. It's like one line of code less. So by making PHP Spec only able to write unit tests, I've saved one line of code for you.
Ooh. But the magic that you needed to...
And there's a lot of magic and stuff if you saw the talk yesterday. So if that fits with the way you're writing code, use that tool. There are loads of other unit level testing tools. I can't name any of them, but there's lots. Simple test, is that still a thing? Okay, yeah, Drupal still uses simple test.
No, it's a thing again. Somebody revived it, I think.
Okay. And there's a bunch of one. Phil mentioned one yesterday that looks pretty cool. It's not about what's best. The important thing is the practice and how you're writing them.
I couldn't care less which testing tool you use, as long as you're testing.
I spend a lot of time writing PHP Unit because that's what the project I go to has. There's no point disrupting it.
So we have 1 minute over, but we have one more dimension.
Yeah.
Really quick. So who is doing this? And what was this all about? Like a TLDR of the presentation? Not TLDR, TLDL. Too long, didn't listen. Don't choose a tool because there's 2 people on the stage in front of you telling you, use this tool or use that tool or whatever. But get a feeling for those tools and find what works best for you. What works best in the circumstance of your team, of your project, of your business, the way that you want to work. And the same goes for every other kind of tool out there. Don't pick a tool because everybody is using that tool and it's the hype of the week, whatever. And because everyone is using it, I have to use it. I don't really care if I have the same problem than the guy who created the tool. I have to use it. And then change everything in the way that I work. No, do it the other way around. Have a good discussion in your team, figure out how you want to work, how you want to structure your development process, and then pick the tool that supports you best in that. Don't bend yourself to a tool, find a tool that does what you want.
And if in doubt, don't use any tools. Just talk to people and understand what they're doing.
Talking is the most important.
Yeah.
Not tool, but skill, thingy, yeah.
Cool. And if you write an open source tool, make friends with the people who write rival tools. You'll learn huge amounts from them. It's more interesting than having a big Twitter flame war or a mailing list flame war about who's the best. Okay. We used some photos. It was a mixture of Creative Commons, things Sebastian paid for, and something I stole off the internet.
Yep.
And I don't know if we have time for questions, but thank you very much, everyone.